So this is about more complex curves, and I'm going to cover these here and then also the polygons at some point. And these two here, this is a web link here, that's a treasure trove to me, as well as this one here, and there's a huge overlap between the two. So these are all interesting, more complex curves. You can already see the equations. For example, this one here is, to me, an upside down mouth if you want to put on a face. And there's a relatively easy way to make that upside down. All right, let's start. Let's start with the asteroid, not asteroid, but asteroid. So I'm going to copy this one here from something that I have already prepared. So there it is. And I'm going to highlight this whole thing. There we go. So there it is. And then I can change this one here, for example. Notice the 2/3 in the exponent. That means you square it and then you take the cube root. Basically, that's what it means. I can make it smaller, and there you go, right? I'm going to leave it at this one here. The interesting part, by the way, is if you change the exponents. Sorry, it took me so long trying to think of this. Yeah, there we go. Yeah, that looks kind of interesting. I'm going to leave it here as 2/3. So there we go. All right, I'm going to do the bicorn next. So that is kind of like, in this case, it's actually the right side up mouth already, because I fixed something in there. The original one actually was, there was a plus here, there it is, and to make it there we go, minus, and then I can turn this one off. For this project, or as I'm instructing this one here, I took a more complicated approach. Notice that we have an a, which is actually a variable here. There it is again. And I believe on the other side is simply, what's actually on the other side? Oh, this is on the other side. The equal is right there. By the way, if we do this, let's see. Oh, okay. If we do this, it's the inside. There we go. And if we do this, smaller and equal, there we go. Then we have that. Or the other way around. There we go. I'm going to leave it at equal for now. Oops, I said equal. There we go. Okay. Since I already put the a in there, I ought to pull down this one here. But oh, there we go. That was actually relatively quick. So it would actually offer me the a here that I'm supposed to do something with that. And then you can change this one here. There we go. And you see what happens to that. All right. Cassinian ovals next. I'm actually going to type that kind of to show you. By the way, I just do an enter to get to the next line here. Respectively, put an equation there. I'm going to show you that it is a little bit of work to put that in. So I'm looking, of course, at some resource here. I don't have this memorized. So there we go. It's always use the dash, the caret on top of the 6 to put that square in and put a 2 there. So here's the caret, put a 2 in, go 1 over, so you're out of the exponent. And then minus 2. And now I don't have to do that times. Could actually leave it out because most calculators interpret that actually as a times in between, but there it is. All right. So here, actually, I'm going to copy the front part because this one will appear again without the square on the outside of the parentheses. And now I'm going to have a to the 4th power. And then, oops, that's actually supposed to be a plus. And then I'm going to have a minus c to the 4th power. Notice what happens when I hit the c right there. It says add a slider. Yes, actually, I do want to add a slider. Just push down one time. And then here 2 to the 4th power equals 0. There we go. And yes, it does look like a circle for now, but if I change certain things here, okay, still a circle, or 2 circles inside each other. Okay, what if I change this one? That's actually... Ooh, that looked pretty cool here for a moment. Okay, as I kind of hinted on, that actually looked a little strange to me. I'm doing this here or that, these 2 circles, but it looks kind of cool. And I noticed the mistake I made. If you look at the equation, which is posted here, right there, there's a minus, not a plus. So when I copied that, I had to change the plus to a minus. These are the Cassinian ovals. That's how it should look like. So let's see what happens. I'm going to substitute a minus there for a plus, and yes, there they are. They almost look like circles, but I think you can see that there's a little bit over there. So let's see. I can change this, by the way. I have a step of 1 here. Sometimes it's nice to have just integers. I'm going to change it to a smaller step so it's more continuous. There we go. And then I connect, right? And I go to 1. And yes, we still have that bicorn in there. And I can push this out further here, smaller. And yes, with my limited screen. So I kind of noticed at some point, if you put that actually with the bicorn here, and you do it right, let's see, I think it was this one, and there we go. You know, when you shift one or the other down or up, you actually could get eyes and a mouth, right? And actually shifting up and down is relatively complicated here because you have to go inside the Y here. So for example, you would have to, everywhere you see a Y, you would have to do, for example, this here. So parentheses Y minus 3. Oh, that looks cool, huh? Parentheses, and then over here you would have to do the same thing. So parentheses Y minus 3, and at this point it is being shifted up. There we go. Pretty cool, huh? Okay, and I guess I'm going to put the asteroid back. Oh, neat, huh? Almost an interesting looking nose there. As I said, shifting them left and right is sometimes a little complicated. Here we go. I could shift that one, for example, to the right by doing that. There we go. Desmos had already interpreted that I should open the parentheses in the front, that kind of thing. You know, if I put a 0 here, it's back to the middle here, or if I just take a 0 out and get rid of the parentheses. There we go. Okay, I'm going to use the lemniscate of Bernoulli, and here it is. And I'm going to open my snippet tool on my computer, and here it is. I'm going to click on New. I'm going to highlight this one here. There we go. And I hope I'm recording this. And then it has this little tool here that says Text Actions. Oops, there we go. Text Actions. And let's see if it's able to do that. There we go. And I say copy all text. And notice where the squares are, okay? So I just copied all the text. I'm going to go back in here, and I'm going to do Control V. And there it is, except for the squares. So I'm going to do the squares here. and all I have to do is highlight it and then click on the Shift caret. There we go. And again, highlight, Shift caret, and over here, Shift caret, and the reason, and here's one more. There we go. The reason why I'm laughed is because not only interpret that particular Y as a G, but that was actually an X. So I guess sometimes it's trying and sometimes it's missing out. And by the way, there should be an extra couple of squares here, so I still have to put those in. I'm going to do that Control C, Control V. Okay, didn't quite work. All right, do it again. All right, there we go, there we go. That's it. Let's see, I'm going to turn the others off. Push it a little bit up and turn off the asteroid. There it is. And again, if I use the slider here because I have the A already, this is really that odd that happens here. These kind of two bubbles that are connected. The lemniscate of Bernoulli. Okay, and the next one I will type. So enter. This one is the Devil's Curve. I don't necessarily like the name of it. It should be lighthearted mathematics, and then they throw the Devil's Curve at us. All right, but it's really, to me, impressive, and it's actually not too complicated. So let's see, as long as I type it correctly. There we go. And almost done, actually. So that's why I typed it, because it didn't take me much long. It didn't take me very long. There we go, equals 0. There we go. Okay. Turn this one off. I think I have to see. I have to pull down the B slider here, because the B slider was already in there, that's why it didn't offer it to me. Okay, so far so good, but that's not the impressive part. There we go, that's it. So, which one did I just pull? Yeah, this one here. I'm going to change this one here to 0.1 as well to make it more smoothly going on. There we go. I think that's pretty cool, that this kind of curve here. Three totally disconnected ones, and there it goes over, right? It flips over at a certain value, and that depends on both the A and the B value, I believe. There we go, they both do that. I think one of them has to be negative for this one to happen. So here we go. If they're both positive, then yeah, this is all we get. And I guess here they connect, and we get that cross. I don't know how that circle got in there earlier. And if they're both, there we go. That's the cool part. And here we go, if they're both negative, well, then it kind of looks more like a hyperbola or flattened out hyperbola, so kind of boring there, but this is where the interesting part's happening if one of them is negative and the other one positive. All right, the next one that I want to do is called the cycloid. It has the word parametric here. So I show you in a moment what that means. I'm going to go over here. Oh, there's a cycloid right there. There we go. And notice that the x and the y are defined independently from each other. In Desmos, I'm not exactly typing it in the way you see it here, but I put the right-hand sides in parentheses separated by a comma, so I don't even write the x and the y. So notice that I will pretty much write this one here. AT minus h sine t, a minus h cosine t. So here we go. Okay, so open the parentheses, comma, close the parentheses. In front of the comma is the x, without writing it actually, and right behind it is the y. So it starts out with a times t minus h times the sine of simply t. There we go. I'm going to turn off that other curve here. And here I'm going to type a minus h, and really the difference is that there's no t toward the front, and the other difference is that this is a cosine. There we go, and let's see what happens. Not too much. For one thing here, it gave me a new variable t, and I might have mentioned this already, that in mathematics, instead of using 0 through 360 degrees, we quite often use 0 through 2 pi, which is a full circle. So here's the 2 pi. Still nothing happening here. I'm going to zoom a little bit out. Maybe I missed it somewhere. It's probably, yeah, definitely. Oh, yeah, there the A value. That's what it was. And we kind of can see it here coming into view. So I have to, oh, it's relatively big here. So what about if I go to 10 pi, for example? There we go. All right. Oh, and then the H. What happened to the H? Oh, that's actually way up here. I also have to pull that down. So there we go. And so if I change this one here, we got that. And we got little loops in there, for example. So yeah, there we go. Oh, that looks almost like a spring. I'm going to leave it at that for now. All right, the next one I'm going to do is the Lissajous figures. They're also parametric. One of my favorite ones, actually among these, it's the one that I've used the most when I did certain things in physics. So a times sine n times t. Again, I don't necessarily have to write the times in there. There's the n factor, by the way. And I have to go back in here and then put a plus c here. It's just a phase shift. And then, oh, there's the comma. And then on the other side, it's simply going to be a b times cosine of t. And then I have to define the t again. 2 pi, usually. Let's see what happens. So it looks like an ellipse. And now with my new n and then the ABC here, this one here is simply the amplitude. So for example, if I go up to 3 here, and here I go to 3, there we go. Again, ellipse. Let's see if I push this one here, we can even get a circle, there it is, and so on. The cool part comes in when I shift the n. There we go. I'm going to make this a little bit more here, not just 2 pi, but 4 pi instead. There we go. And I'm going to shift the n again. And if you look here, notice that they don't have a p. I'm sorry, they don't have an extra factor on in here, and we could get this here, for example. But I'm going to put one in there. I'm going to call it p. So p times, and it says add slider. There it is. And now, there we go. This gets interesting here, right? This almost doubled. Notice the 2 to the 1 there. Here's 4, and if I go to 3 here, at least I'm trying. There we go. And if I do the C here, then this is what's happening. Minus here, by the way, doesn't really matter. Happens in both here. And what we can see here, for example, you see the 4 and the 3 here, and then you count these here, 1, 2, 3, and you count it here on the side, 1, 2, 3, 4. So wherever they're bulging out, and if I change this one here to the 6, for example, yeah, look at this, wow. 6, and I change this one here, for example, to a, yeah, sure, 5. And now if I count the bulges, I'm going to do this one. Here we go. Okay, so if I count these bulges here, it's like 1, 2, 3, 4, 5 on the top, and on the side, it's 1, 2, 3, 4, 5, 6. So these are Lissajous figures. All right, last but not least, I'm going to do a spiral. So I think this is called the, what was it called? The equiangular spiral, and it's polar. Polar means that it works with, instead of x, it's working with r and theta. So the radius and the angle. So I'm going to have a equals a times, notice it's already offering me the theta here, times, and then I'm going to have the e to the power. I'm going to start a parentheses there. I'm going to type in theta. Oops, I meant to start a parentheses. There we go. Theta, and Desmos knows what that is, times the cotangent, COT, of some fixed number c. And I'm going to turn the Lissajous figure off, and then it actually offered me 12 pi here. I'm going to put 22 pi there because that's what I have in my, so this is actually quite large. That's what I have in my notes here, and the C, might be the C here that is kind of conflicting here. There we go. I'm going to go here, C2. So there we go. There got a spiral, right? And now I'm going to zoom in and watch what happens as I zoom in further and further and further. I don't know if there's a limit to this one. I'm actually at pretty small numbers. This is 1 over 1,000 right now. So I guess it just goes on here, and I'm going to zoom out to where we were. All right, so these are the complex curves that I wanted to introduce. There are more, but you know, this is plenty, right? So I'm just going to turn them on here all at once. It's kind of pretty. All right, so now I'm going to do polygons. I'm going to turn this one off first, and it's going to be similar to what was already shown for the sailboat, or the way I made the face. No, actually it wasn't a sailboat with the polygons. So here we go. Let's say I want to build a house. I'm going to build my house approximately here with the roof here, and then we'll see. So I'm going to start out with table. I'm going to start over here. So this is 0, 2 because I'm on the axis. So 0, 2. Nope, it's the other way. Other way. There we go. Wrong point. 2 and 0. I'm on the x-axis, which means I'm 2 over and 0 up. And I'm going to go over here. I believe I'm going to go to 6. So I'm going to go 6 is the x, and I'm still 0 up. Okay. Earlier, I made a mistake when I first tried this, so I'm going to show you my mistake here. So my next point I'm going to put in here is a 2 and 2. And I'm just telling you, it's going to not work out very well. So there we go. 2 and 2, and then 6 and 2 over here. So far so good, that's okay. But now I'm gonna hit enter here. I have to click somewhere else and then hit enter. And now I'm gonna put the polygon in, and you see the x1, y1 there here, so I'm just gonna tell Desmos polygon. There you go. x1, comma, y1. There we go. Yeah, this is what happens. So, oops, all right. So I'm going to switch these here. I ought to draw them in succession as such. I've got a triangle there, I guess, for time being. There we go. So here's what happens. This is the way I have to put them in. So I start here, 2 and 0, 6 and 0. Then I go up, so 6 and 2, and then I go over here, 2 and 2, in order to get my nice square. So that would be the house. Okay, now I'm going to do the roof. So I want to start here. So this is going to be 2 and 2 again. There we go. And you know, also notice that I had to highlight this earlier for these dots to come in. And of course, if I turn this one off here, then, oops, if I turn this one off here, well, we don't see it. Okay, so back to this one here. I'm starting with 2 and 2, which is here. Since it's a triangle, it really doesn't matter which is going to come next. So I think I'm just going to go here, which is a 4 and 3. I can see that. 4 and 3. There we go. And the last one ought to be over here. So that's going to be 6 and 2. 6 and 2. And then I'm going to tell it to do a polygon, and I can do that with Control C. Click on this one here. Okay, there we go. That's good. And Control V. That's basically actually the same one, but I have to change it to X2 and Y2. That looks kind of cool too. And there you go. There's my roof. And then I guess I could maybe change the colors here. I got a blue house and an orange roof, I guess. There you go. I'm going to put this one right beneath that table there. All right, enter. And I'm going to zoom in a little bit more. I want to put a chimney there. So I'm going to put the chimney starting kind of like, yeah, sure, let's do this one here. That's actually a 3.5 here. I'm going to zoom a little bit out so I can see these numbers better. There we go. So I want to make a relatively tall chimney here. I'm going to start here. So 5 and 2.5. So table 5 and 2.5. So there's my first point. I'm going to go up here, and that's going to be still 5 and 3.5. 5 and 3.5. There we go. And then I'm going to go over here, so that's going to be 5.5 and 3.5. And then the last one is this one here. Ooh, that's a little interesting. I'm going to try I'm going to make this a 5.5 again, more or less, obviously. And I'm going to guess that this is a 2. Actually, I think it's a 2.25. There we go. Right on there. All right. So there it is. And then again, I'm going to copy this one on this polygon here. I'm going to go in here. All right. Down. Paste it in here. And of course, change this to a 3. And there we go. And again, of course, strange things could have happened if I had switched a couple of them. For example, if I had done this one here to 2.25 and then this one here 3.5. There we go. Okay, that's a weird looking chimney. Control Z to take that back. Several times over. Sheesh. Several times over. There we go. And then I guess I'm going to make my chimney to be black if I can. There we go. And these are also transparent. These can be adjusted here. I think it's with the fill. So I can make one here completely, or I can make it quite transparent like that. And I'm just going to leave it at the 0.4 that they gave me. And then when I did this little house here, I figured, what about if I put some smoke in there? Because there is actually a curve that lends itself to it, which is the cycloid. So I'm going to go back up to this one here. So the cycloid is one of the last ones. It's the parametric one. I think this one here is the Lissajous, and this one here is the cycloid. So I'm going to take this one here, Control C. Close this folder, go back in here where the polygons are, and actually, one moment here, I'm going to have to push this one into the folder for the polygons, and then certain things. There we go. I'm finally getting it. And this one here, and I finally can put the Control V there, so I pasted that, and now I'm going to take the numbers out here. I'm sorry, the slider's out here, so I'm just going to do a 1 here for A temporarily. 1 for the H. The T is there, and I'm going to do a 1, and then I'm going to do a 1, and let's see what happens. This one here ought to be 2 pi, something like that, and there it is. Okay, definitely not a smoke thingy, right? But I can do a few tricks. I can make this one here going like this. Ooh, that looks interesting. And make this one here. There we go. 6 and 6, right? So here we go. If I was able to turn that one now, it would be vertical, and it's actually not too hard to turn it. You see that T here? I'm going to take this one out, and I'm going to put it here. Now it's vertical, and now I need to shift it just right. So I need to shift it to the right, which means this number ought to be larger. Yeah, it's almost there. And this number here, I actually have to put a number in the front. I'm going to try 2 plus. Okay, a little bit higher. I'm going to go with 3. Okay. Almost. I have in my notes actually that the 3 would work. Oh, there we go. And then this ought to be smaller. Okay, so I'm going to do a 1/2 here instead, and a 1/2 over here. And I think I want to leave it at that. That looks like good enough smoke to me, I guess. Maybe change the color. There you go. Yeah. So that's my polygon exercise example.